Welcome to another data science deep dive in our technical track. In the following session, Subash D'Souza, Director of Big Data and Ops Intelligence at Warner Brothers, shares that one of the major aspects when it comes to ingesting and processing is understanding how to bring all that data together. Today, over 70% of data analytics is actually spent on cleaning and parsing the data so the value can be derived from it. But this is not only trivial due to the large volumes of data sets we deal with. This talk will go over what it takes to understand how we could set up data governance principles that could be adhered to by everyone in order to create a better and quicker analytics system. Enjoy.
I'm Subash D'Souza, so it's pretty simple, but so hey guys, I'm going to today talk about enterprise data governance. So before I get in there, how many of you are interested in lunch today? Yeah, perfect. Yeah, I want to make sure I get you guys to lunch soon, so we'll go through this slide deck. But one of the key things I want to talk about is, you guys have been listening to AI talks, machine learning, data science over the period of the morning. What I want to talk about is actually the unsexy side of data science, because this is a lot of the time data scientists and machine learning engineers spend, it's probably about 70% actually on this side of data governance. And the reason being that you actually have to do a lot of data cleansing, data munging before you actually get into a form or a source that you can actually use to actually process your data or put it into models or build feature sets for. When I get into talk about what this actually means, there's a lot of things that data governance means. But before I go, I just want to mention a few things about myself. So I do organize conferences outside of Warner Brothers. I'm an organizer for DataCon LA, formerly known as Big Data Daily. How many of you attended the conference last month? So pretty huge chunk of you guys. I do a lot of other things. I run the Big Data Users Group, Spark Users Group, also advise, invest. And I also am part of the Data Governance PMC for member as part of the Linux Foundation. One of my key things as my daily activities is understanding how data can be used in various forms, in various organizations, various enterprises, and that means understanding what data means from a very basic fundamental set. Over the period of years, if you have sat through multiple organizations, multiple enterprises, data is never the same. Data is evolving, ever-changing, and that causes a lot of problems. Also, the same data sources can exist in multiple different forms, in multiple different assets, in multiple different organizations. And that means how do you handle that kind of data changes? So some of the attributes of enterprise data governance are, when you start talking about what enterprise data governance are, start looking at data architecture management, data development, data operations management, data security, master data management, warehousing, data document content management, metadata management. How many of you have dealt with bits and pieces of this? If you're a data engineer, you're a data scientist, you have to do some of this. Data cleansing, most of you have sat through it, and tried to understand what that means, how data is cleansed, how you can get into a form that can be actually be reused for use by the actual data scientists as well as data consumers in general. And we'll talk about a little bit of each of these problems and identify how we actually do that at Warner Brothers as well as other companies that I've worked with. So what are the challenges with enterprise data governance? And I call it enterprise data governance because people have called this terminology such as data governance, and the kind of, mishmash, and it kind of focuses on very siloed piece of it. To me, I look at enterprise data governance as a whole feature set of how you want to do these things. So we talk about, and my previous slide basically talked about it, things like metadata management, data quality management, data lineage, data security, data development, master data management, metadata management. All these things are, as I look at as encompassing enterprise-wide feature for enterprise data governance. So what are the challenges? Poor data quality costs real money, process efficiency negatively impacted, full potential benefits of new system may not be realized, decision making and negatively affected. So just give you an example. When data is consumed, if you have, for example, if you're buying data from the same data source across multiple different organizations, like for Warner Brothers, we are an entity consisting of three big entities. So we have Warner Brothers, HBO, and Turner. And now, many of you have probably heard we got bought over AT&T. Each of these organizations, they have their own internal metrics of how they purchase their own data sources. There's a possibility or chance that we possibly buy these data sources from the same data entity. That means we are paying for the same data sources multiple times over. We shouldn't be doing that. We should be looking at consolidating these licenses into one. Other challenges we look at, how is this from a data perspective, like from metadata management or master data management? If you have multiple data sources, multiple data entities, for example, the dark night, now we treat them differently in how we actually use the data. For example, dark night as a DVD, dark night as a Blu-ray disc, or dark night as a digital entity. Each of these are treated differently, so they have different IDs associated with them. But technically speaking, each of them are actually the same. When we want to calculate the financials across them, we want to make sure we tie them in together. The problem is there is no parent ID that ties them into together. So we have come up with systems to merge these data sets across multiple different platforms. We look at OTT, we look at different kind of streaming platforms as we progress into these kind of data sources keep increasing over the period of time and become a challenge when you want to bring them together. So objectives. So you guide information management decision making. You ensure information is consistently defined and well understood. Increase the use and trust of data as an organization asset. Improve consistency of progress of projects across the organization. Ensure regulatory compliance and eliminate data risk. It's a bunch of stuff out there. I just mentioned about what you should be doing, but the key thing to understand is that it brings efficiency into the board. A lot of the challenges I see today is that because of the way you access the data, it causes a lot of problems. All of our data today is Amazon S3. The problem is we don't have one single way of accessing the data. We access the data through multiple. So we access them through Tableau, through Looker, through multiple different methods. Through Spark, writing code that access the data. We directly go to S3. Problem: each of these bring their own challenges. If you don't have a consistent way of accessing data, you could have a huge problems that define. And let me talk about this from a perspective of GDPR. How many of you have heard of GDPR? It's a fundamental, most key thing that's happening in all organizations today. If you haven't heard of GDPR, then your organization is probably not impacted by what's happening. GDPR is basically this European law that's come out and it's been in effect since May. If you're not in compliance, your organization will get hit with a 2% or 4% of your global revenue. I think Google was hit with $2.5 billion recently, and they're looking at hitting more and more fines, which is with the non-compliance with GDPR. But GDPR basically says that if you don't get rid of consumers' information within, I think, 7-day period or so, 7 or 10-day period, you could be hit with a possible fine. So people are scrambling to make sure they are in compliance with your systems. So this also means that you need to ensure when people access the system, you get rid of all of these PI information that people have asked to remove. Sometimes it's very tricky because you've already aggregated information, you already put it into like reports, canned reports, whatever, and sometimes that's people don't want the information as part of that. So you need to re-aggregate, reprocess your data. So that requires a huge challenge of how do you bring everything together and make sure everyone is in compliance with this requirement that only one source of truth is there out there. But here's the problems that I'm going to ask you. I mean, let's assume you have a source of truth. You have only one way to access the data. Do you know what challenge that brings? Can anyone think about what's the challenge that brings when you have only one source of truth to access the data, or one single point? Can anyone think about it? Bottlenecks, exactly. It's a performance bottleneck. Everyone is going to access the data from that single point. What if it becomes a choke point? Everyone is accessing data, you're not able to service the data, not able to provide the result set that you want to the end user, the data consumer. That becomes another problem set because then now people can't access the data. So what's the point of having all this data? So, someone has mentioned earlier talking about, Snowflake and Delta and all, and I've looked through systems, they're good, but they're all niche products. They only work for very single specific use cases. As an enterprise data governance solution, they don't work very well. So you have to figure out how to make a product that's scalable. That's a challenge. It's a huge challenge. Even what I'm talking about today, we have implemented bits and pieces of this. We really cannot scale this out because there's any product out there today that talks about data governance, they only look at very specific niche aspects of what data governance is. And I'll talk about some products we looked at and why we also went with our own solution that looks at implementing data governance as a role as your own. So problems in master data management, discovery cannot find the right information, integration cannot manipulate combined information, dissemination cannot consume information, cannot extract value and virtual information, cannot manage growth and control. So these are problems master data management. Before I get to that, do people understand what master data management is out there? You understand, the concept of master? So just a basic example, when you have multiple sources of data and they kind of look the same or they are the same, but because of data entry, someone types in dark night, but instead of dark night they type in dark K or they miss the K and they put dark night. They're typically both the same part of the same feature entity, but because someone mistakenly entered that, they become a problem set, because now any system that uses it cannot actually merge the two data set points. So master data management is something that you have a feature set rule set that makes sure that these kind of problems that if they do occur, they can be merged together as one entity in the final output report. So this was a survey done by an organization. I forget who exactly did it, but they actually went through and talked to the CIOs, management directors, and to figure out what exactly the problem sets defined in master data. So they said 52% of users don't have confidence in the information. That's pretty confident. If you go to your consumer today and say, hey, how confident are you in the data set, or how confident in the output of the report? A lot of them don't have confidence. That's because most of the time they're saying, hey, where this data source is coming from? Is this data source cleansed? Is this data source in the form that I want? And they're concerned that when they see the report, they see multiple reports with different results, and they come to you, ask you, hey, I tried this, using Tableau. I tried this using, Spark or something like that, and I see different results coming. Why is that? And you have to go back and say, oh, this one has this particular feature engine, or this particular rule set that defines that I cannot use this particular output. Hence, you're seeing this output out there. So the consistency of that is very difficult to apply across multiple different, consumer sets or reports unless they talk to the same rule set engine. 59% of managers miss information they should have, and that's very common because they don't know what data exists. If you don't know what your data of the data catalog exists, you don't know how to actually access the data. 42% of managers use wrong information at least once a week, very common. 75% of CIOs believe they can strengthen the competitive advantage by using and managing enterprise data. 78% of CIOs want to improve the way they use and manage the data. Only 15% of CIOs believe that the data is currently comprehensively well managed. Does anyone, feel this pain? Anyone? You can just raise your hand. I'm just kind of curious. How many of you have seen these kind of problem sets in your enterprise organization? Quite a few of you have seen it. It is there, and I don't doubt it. When I was at Toyota too, we faced this problem. And that's working on scale. Imagine working on a engine or a car that's trying to do real-time driving, and you have these problem sets that happen. If you make a mistake when in a real-world situation, that could complicate or create a problem set that get cascade down and could cause even an accident for that matter. So you want to be sure that the data you have is cleansed, is ready to go, and it's perfect from the get-go. But that's very difficult, just because the way data is consumed is not the actual way you actually want to consume it or process it for that matter. So what is metadata? Metadata, I won't go into much of it, but metadata is basically data about data. The thing about data is that, when data is formed, when the data is actually created, there's actually information that it comes on. And that could be information, for example, data source. What's the data? Google Analytics is a very common piece of data. If most enterprise organizations have some kind of Google Analytics code set up, that means that you always want to know what piece of information has come in from Google Analytics. There could be, for example, there could be a YouTube video that people have consumed, and you want to know if that's tied into your particular organization. For example, for Warner Brothers, we have trailers out there. You want to know how many people have consumed or watched the Nun. How many of you have seen the Nun trailer? I've heard about the Nun trailer. Yeah, you've probably heard about, it was probably a marketing gimmick on Warner Brothers side, but it got pulled because of violating YouTube's rules, basically being that there was a big scary episode or a scary piece where the nun just popped up at the end, and people were starting to get scared. I mean, it was good marketing viral because the Nun made over $53 million over the last weekend, so good for Warner Brothers. But at the end of the day, we want that kind of information. We want to know how many people actually watched the YouTube trailer before it got pulled, and that kind of also, talks to how Warner Brothers can use the information to use the marketing dollars. Where should the marketing money dollars should go towards? So metadata needs to be managed to ensure metadata needs to be stored where it can be accessed and indexed. It needs to be consistent quality, needs to be kept over a period of time, and it should be open. I know people say data should be in this PIA data, and you want to make sure that data is encrypted and all, but metadata should never be encrypted. And I believe the reason I believe that because you want to make sure that people know what data do you have, where the data is stored, and how to get access to it. Now, once that's done, you can obviously say only these person or these data group set of users can actually have access to data. But at the same time, you just want to make sure that people know what data is available, even if they don't get actual access to the value of the data, what the data actually means. So metadata lifecycle is larger than data lifecycle, and this is actually true because data, depending on how long it's consumed or what's its life cycle, metadata will last as long as that. So directly from the source, through its transformation, through where it gets stored, and through its final consummation, everything is part of the metadata life cycle. Hence, you will see the metadata stored and created at every step. Every transformation will have some metadata created. Every time it's consumed, you'll have some information being created, and that's always being available for use. And you can also think about this from a security perspective. You do want to know who actually touched the data, and that could be metadata. Could be part of user A touched this particular aspect of the data at this particular point in time, and you can also come back and say, should have user A actually have access to the data? It could be yes or could be no. What's data lineage? And this is the other aspect of it. Whenever you go through these changes, transformation, data, whatever that may be, there's always a data lineage being created. And you want to keep track of that right from its source. For example, you're processing a bunch of data sets from point A and goes to finally point D, which is the consummation part. But at every step, you want to know what exactly happened to the data. At point C, you want to know actually what data sources were consumed to be available at point C, and you want to make sure that it has actual right data sources involved in that. Data lineage is important from that perspective. And if you don't know what has happened at that step or the report step, you can't really be confident that the report you have is actual right value, the right content of the set that you want. That's why data lineage is where it comes important. So you can always pull up the data lineage for any report and say, yes, it has the right data sources, yes, it was properly transformed, and yes, I can use this data going forward now. Data quality issues, again, obviously all of you have faced this. You're going to see data quality. None of the consumers or data sources that you have, no matter how good, even Google for that matter, will always be accurate in what they say. For example, we have noticed Google, not very often, but sometimes it does happen, they fail to send us the data on time. Sometimes it's an hour delayed, sometimes it's 24-hour delays. Obviously, we have processes in place to ensure that we can pull the data or be available to handle those use cases. But again, it's something that you need to be aware of. It's all data engineering pipeline processes that need to be handled. Again, these are not the most glamorous features of data engineering, but it needs to be taken care of. Because at the end of the day, when you give these reports out, you want to make sure the consumers of reports are highly confident of what the values you give them. So quality life cycle. So data profiling process reveals unexpected personal data. So just an example of how you do data discovery. Business rules, you set up a bunch of business rules that identify original source and unexpected personal data. You create routines to ensure that personal data is removed. You do data validation routines, and then you finally do integrations. And as expected at the end, analytics and reporting API for GDPR. So this is just an example of how data quality will be defined in any particular enterprise organization. The other aspects about this, data catalog. So one of the key features, and I believe very strongly this, you need to have a data catalog, and this is something that you want to expose to all of your users. From a perspective, data source and systems, you'll see most ETL developers and integration specialists, they work at the raw data level. But when you start looking at atomic data like warehousing, raw zones, that's where your data scientists come in the picture. That's where they pretty much look. But before they touch even any of this, it's up to your ETL developers and specialists to actually put the data into these places where your data scientists can work. Finally, you have your report developers, business analysts, and business users that will actually use these information sets that you define, but they only come in at different data points, such as the data marts, data sets, definitions, and then final reports. So each aspect of this is that you need to have a data catalog available. So each of these groups is aware of what are the data sources or what data points are available, so they can make informed decisions on how to use these data sets for in the final end reports and for those reports. It's very key because when you work with multiple different consumers of the data, each of them have a different viewpoint of how this data should be used and how they should be consumed. And each of them need to be aware of what the data sources are. It could be they have Google Analytics, it could have third-party data aggregators, Accelerate, Axiom, Blue Crux, etc. And you want to make sure that each of them are aware that we have all these data points, and you want to combine them into different ways of actual data so that they can be consumed by end users. So how is this, scoped out? How is this, project? So if you look at each of these points, I've talked about them. So we look at data security compliance, data catalog, data quality, lineage, metadata management, MDM. Each of these add value over a period of time that you need to have. Each of these points are what we look at as enterprise data governance strategy in any organization. Business value add, some of the things you look at revenue. If you consolidate your data sources into one, you're not paying multiple licenses over again. You increase business value because now people know what data sources you have. They can even make informed decisions. Your data scientists, for example, if they know what's the entire breadth of data sets they have, they can start building new use cases. Typically, the way it works is that, and today what happens is one of your end users come and say, hey, this is a use case I want to build against. But what if your data centers can actually come back and say, oh, I see all these data sets out there. Maybe I can build 10 different use cases and then show it with my end user, my consumer, and my consumer can come back and say, oh, this makes sense or this makes sense, and they refine that. That cannot happen if there is no entire view set of what's your data catalog, what data sets you actually have. That never happens. That's typically what I see today. It's always the end user coming in telling us what my use case should be. Whereas I believe it's the data center should also come in and say, these are my data use cases I believe I can build for you. Do you think they add value? And there should be a back and forth between the end user, the consumer, the business user, and the data scientist. And that can only happen with having an enterprise data governance strategy. Agility, you move faster. It's very easy because it makes sense because now you know what your data sets are. You're able to make quick decisions on what you need to be. You're also more confident in your actual output. That's why you're going to be more agile. You reduce your costs, obviously, and you're in compliance. Now you know if there's any compliance, if there's any GDPR requirements, security risks, you're in compliance with the organization rules and directives. So this is a proposed solution that we will be looking at building a service-oriented architecture. And I'll show you the actual architecture we looked at building. It's a pretty complicated model and we're still building it out, but it encompasses a wide variety of tools and technologies. Part of it is, buy, a lot of it is build. So people talk about build versus buy. I'm more of a build solution, but it's very complicated. We really can't build everything out. So we're looking at even buying. And problem is we can't buy everything because there's no product out there today that satisfies each of these problem sets across the board. They all are very niche. Also, they're very expensive. And we really don't know if they satisfy the problem sets we have defined until we actually test them out. So this is the architecture we defined, and this is how we're kind of building it out. So the bottom layer we have the infrastructure, network, storage, databases, messaging, transport, processing. Each of these workflows is each of the engines that we're building out. Data security, each of the points, PI, GDPR, compliance, access controls, encryption, anonymization, obfuscation of data. Data catalog, data discovery, obviously, making sure that whenever we get any new data sources, it becomes part of our data catalog. Classification of data, tagging, documenting, publishing. Data quality, we cleanse the data, quality of the data, completeness, accuracy, consistency, lineage, data source, logical ordering, feedback loop, workflow, metadata management, management strategy, metadata capture, metadata storage, master data management, and then distribution of this data from, we have HTTP protocol, FTP, TCP, UDP, databases, files, and then on top of this, we build a service-oriented architecture. So this one basically means that everyone is communicating through one single point. Even though it's a choke point right now, we're looking to scale that out and create multiple different HA points so that it doesn't become a choke point. But then we make sure it's service-oriented architecture where everyone communicates through one single point. That could be multiple. It could be an API process. It could be just be direct calls. But this is how we're defining that. So web services, service registries, messaging, auditing. On top of that, business process architecture, we build a rules engine because obviously you need to have a rules engine to ensure it's consistent and compliant across the board. Search process, we're ensuring, you can type in searches. We use Elastic today. We're trying to get better at making sure we're able to catalog and categorize and make sure it's discoverable. And then you have users or internal upstream systems. This is within the organization. External systems, people outside the organization, user interfaces, and B2B users, B2C users. So this is one of the use cases we actually built out. This is master data management. And the way we build this, we're using 70-30% architecture. 70% basically means we have built an AI model that basically goes to the data that we have, tries to tag the data, make sure that we are in compliance, make sure that the data meets certain parameters and they can combine the data from multiple different data sources. We use 70%, 30% because we believe that not all data can be accurately mastered. And that's because sometimes it's difficult to identify if two different data points are actually the same. So we actually do supervised learning. We keep training, we keep increasing our data, so our training points as we go, and we keep adding more and more data to the training sets to ensure that our training models get more and more accurate on how they define. Today, we look at 70-30% because that's how much we're actually looking at. We want to get more and more better at this. But what basically happens is that we get multiple different data points from multiple different data sources. When they come through, we send them through a data cleansing engine. The data cleansing engine is where the AI model sits. It looks through each of the data sources, see if any of these data sources mean the same. If they mean the same, it automatically tags them, puts them together as one, and then pushes it back down into the lifecycle. If it cannot identify that, it redirects it into a different system. And that's why we have manual people actually sitting down, looking through these different data points and identifying if they mean the same or not. If they mean the same, they'll put it back into the training system. If they're not, it also puts them back, but it is more for making sure that the system model understands what are actually the same versus what aren't. And then it goes back into our data merge curation and then keeps a clean copy of that. We also keep the original copy just for completeness sake, but we delete it after a certain period of time. Sorry. Oh, okay. So I'm almost done, but I'll just quickly go. I think this is my second to last slide. Okay. So how does this work? It's not a walk in, it's not a run, it's not a marathon. It's actually baby steps. You have to start small. And today what happens, today we are actually at the walking stage over there, but at the paragliding stage is where we actually want to be. It takes a lot of time, it also takes a lot of effort. It also means a lot of policies need to be set up in place. The biggest problem I see is you have multiple different consumers of data. Not all of them are following the same data strategy. You need to train them, you need to teach them, you need to make sure they're in compliance. So the single weakest point that we have today is not the actual system, it's actually the humans. Humans and people are very aggressive who want to have things, and you have to work in that agile manner, but that also means that you have to train people, you have to make sure they're in compliance. So this one just basically talks about why it takes a lot of time and how it works over a period of time. But it's also one of those problems that you see. How do you do this, and how do you make sure you work towards going towards this paragliding phase? It's not a marathon, I would say. Again, it's very much a slow pace moving forward. And if you, I would love to hear thoughts about from any one of you. If you guys have mastered any important pieces of these enterprise data governance, but what I feel is that it will take time for any organization to get through it. And from that perspective, that's why it makes it more and more important that you work with your team and your organization to build an enterprise data governance strategy that works for the company.
Okay, my darling, it's time to wrap for lunch.
That was Subash Dassault, Director of Big Data and Ops, Data Intelligence at Warner Brothers, with his presentation on what it takes to understand how we could set up data governance principles that can be adhered to by everybody in order to create a better and quicker analytics system. If you'd like to watch more videos like this, you could subscribe to the DSS Insider program, where you could see our complete on-demand video repository from a wide range of topics on your own time. Subscribe now, following the link in our video description below, and also please subscribe to our channel. Thank you!